Yeah, comes on everyone. Okay, great. So last thing we did was this. Next thing, the most important thing, areas and volumes. So let's start with something simple. Let's start with a disk. Now I know you guys know the results, but physics merit questions won't come always in that way. So for example, if you take a disk, we have a radius r. We want to find the area of the disk. Okay? So listen carefully. I'll show you 1-2 models, then I'll ask you a few more like this. So the idea here is, others, you need to keep your cams on, or else you'll be removed from the classroom. So yeah, let's see how to do this thing. So whenever you see a disk, the first thing that should strike is, how do I choose the elements? So this is what we do. At a distance x from the center, consider a ring, right, whose thickness is dx. One second, let me take the attendance. Aditya, you're new today. Okay. So we take a thin ring of thickness dx. So what you have is a ring like this of radius x and thickness dx. So consider a ring of radius x and thickness dx. Remember what is dx? Dx means very, very small distance. Now what you do, take a scissor and cut it here. So if I cut this, what will I get? I will get a rectangle. Agreed? What is the circumference of this rectangle? 2 pi x. Because that inner length, whatever is there, that will be the circumference. And what will be the width? Dx. So what is the area of the strip? So area of this thin strip is length into breadth, which is 2 pi x into dx. So basically we call this thing as dA, the small area. So if I add all the areas of these small disks, won't I get the full disk? Small rings, won't I get the full disk? Are you able to imagine the shape, how it is? Ever seen an onion ka slice? If you ever seen an onion ka slice, doesn't it look like this, rings upon rings? So area of the disk is nothing but summation of all the rings. So that is the meaning of integral. Integral of area of rings, which is integral dA. which is integral 2 pi x dx. Now here limits. What are the limits? Where is the first ring? Where is the first ring starting? What value? The ring starts from x is equal to 0 and the rings end at x is equal to r, isn't it? So that is the meaning of limits. Where are you starting from and where are you ending? Rings start from x is equal to 0 and the last ring is at x is equal to r. So the limits here will go from x is equal to 0 to x is equal to r. 2 pi is constant, so just put it outside. This guy will be x dx, 0 to r. You know, x dx ka integral, x square by 2. So 2 pi x square by 2, limits will go from 0 to r. 2 will cancel. We end up with pi r square minus 0 square. Therefore, we get area of the disk is pi r square. Are you clear how we using integration we got the area? Again, listen what we did. We have a disk at a distance x. I took a disk, but thin thickness, meaning very thin strip. Let me see if we can get that photograph. Yeah, I got a good photograph. One sec. Getting it? So we took a thin ring here of thickness dx. So this ring ka circumference is 2 pi x and this thickness is dx. So when I cut open this, what you get is 2 pi x into thickness is dx. So length into breadth is 2 pi x dx. Getting it? And then we integrated this. So when you integrated this, x dx became 2 pi x square by 2. Important thing is the limits. Limits are going from 0 to r. Because the starting ring is 0 and the outer ring is this, and this is pi r square. Please have a look at the steps. So the important thing, whenever you see the disk, the elements you have to take are rings. Let me see if I got this. There. If you ever seen an onion, this is how it would have looked, isn't it? Ring upon ring, ring upon ring. So if you add all those rings, you'll get a disk. Rings in an onion. The idea was the same. And the whole reason it works is because the disk thickness is so small, the ring we can use approximation. There is another way to do this actually. See, another way to do this thing is when you took this disk and when you're going to cut this into rings, ring, 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 and so on. So this is what I will suggest. See, I will take the rings and I will start putting them one upon another like this. So this is your outermost ring. I will take the outermost ring, I will open it and I'll keep it here. What will be this length? 2 pi r. Then I will keep the next ring on top of it, next ring on top of it, next ring on top of it. When I keep all those rings on one on another, what you get is a triangle. Is that making sense? Where the center x is equal to 0. So this point is that center O. What will be this height here? This height is nothing but this radius, isn't it? What is area of a triangle? Half base into height. So base is 2 pi r. Height is r. Area is pi r square. You're getting this? So when you took elements and elements and elements and you added, what you got is a triangle. I hope this logic is making sense. So please have a look at these elements here. Quite important. You will encounter this like a pretty standard one. If you see, I was just teaching this something like this today. So there was they won't ask exactly elements like this. The question was something like that. So there was a disk like this, and we have to find. See how we took an element there. We took a small ring and then we solved. So whenever you see the question, the elements are rings. If I show in one more chapter. Here. So we have a disk here, same logic. We took a small ring here, 2 pi x dx. We cut it, exact same story. And then we solve it. So these ideas will keep coming everywhere. So when it comes again, I'll show you. But for now, you should have this idea. Have a look at this. Clear? Show you one more. So we are actually not interested in that area part. We are interested in how did you choose an element. If you understood this part, that you choose an element like this, and the area is 2 pi x dx, I think you're done. All clear? Aishwarya? Anya? Clear? Soham? Om? Achita? Got the idea? Great. Now let's take a non-uniform disk. Now every time disks won't be similar. They won't be uniform. And did you notice something? Was the integration tough? The integration was the most easiest part. The headache is always converting the problem to integration. So non-uniform disk, we define something called sigma. Sigma is mass per unit area. So we have something here, sigma is equal to some constant, let's say some constant into R. C is a constant. X is distance from center. What do you mean by this? Now try to understand. Sigma is equal to Cx, meaning if you have more X, you have more density. This is a non-uniform disk. So let me complete everything. So this is mass per unit area. Example, if someone tells you sigma is 3 kg per meter square, this implies 1 meter square ka sheet has a mass of 3 kg. That is the meaning of sigma. Right? And here x is the distance from the center. So x ka value lies between radius r to 0. Just listen, I'll explain you one completely and then we will see. See some constant. So the question is find mass of the disk. Now the problem is generally if that sigma was constant, I could have done like this. Mass is nothing but sigma into area. Agreed? Because mass per unit area, so mass into sigma into area should give you this. So sigma is given and area is pi r square. My job would have been done. The problem is this. This disk which we have, sigma is equal to Cx, meaning look at this. When x is 0, there is no mass. At x is 0, there is no mass only because sigma is 0. At x is equal to r by 2, so sigma is sigma c r by 2. So mass increased. So there is more mass. At x is equal to r, sigma is even more c into r, there is more mass. So if you look at this disk, this is how it looks. So it has no mass, little more, little more, little more, and very heavy. That means someone must have made the disk like this. So inside it is made of thermocol, maybe then it is made of wood, and then it is made of iron. You're getting different layers are made of different materials. The disk density is changing. Getting the idea? That is the meaning of a non-uniform disk. It is not uniform everywhere. Every instant the density is changing. So basically the disk becomes heavier as you go away from the center. So we want to find a mass of this kind of disk. Again, don't worry too much about this stuff. Try to grasp it. Again, when they actually come in the problems, I'm going to teach you again. But we should have an idea now as we go out. So how do we solve this question? So listen carefully. I'll show you one and then I'll give you one more like this. The only formula we have is what? Mass is sigma into area. Agreed? This formula we know. Why can't we use this directly? We can't use this directly because sigma is changing for every point. So how do we proceed with this? One second. So at a distance x from the center, we take a thin ring of thickness dx. So now we have a thin ring. Thickness as dx. So if I cut open this, we will get a this thing where this is 2 pi x, the length, this is dx. So idea is the same. So the area of this thin strip, dA, is area of that thin ring is given by length into breadth. Fair enough? Now, sigma is surface density, yes. We wrote na here in the beginning, sigma, okay, we didn't write, but the actual technical word for this thing is surface density. Mass per unit area, it is called surface density. In school, what you studied rho is actually volume density, mass per unit volume. Now look at this thing. Since the disk is so thin, right, I can assume almost sigma is constant, isn't it? Since the ring is so thin, we can almost assume sigma is constant for that thin ring. Isn't that the whole idea of integration? If you remember the integration ka starting, how we started the whole story, isn't that how we started the story? You're taking such a small x, we can ignore this error, isn't it? You're assuming the height is almost constant by making it very small. That was the whole logic, that the error can be neglected. So by assuming a very thin ring, so we get dm, which is mass of that ring, will be sigma into area. What is sigma? C into x, which is given. What is the area? D into A, which is 2 pi x into dx. This is the mass of the ring. You want to find mass of the disk. What should you do? You should add all the rings ka mass. Integral dm ring. So this would be integral 2 pi c x square dx. Again, the x ka values will go from 0, center to the outside point r. 2 pi c is constant. This is integral x square dx from 0 to r. That would be 2 pi c r cube by 3. So the disk density is changing at every instant, but I can still find the mass using integration. Again, what did I do? Listen carefully. Same story. I took the disk, distance x, took a thin ring, thickness dx. The area of the ring is circumference 2 pi x into thickness dx. Mass of this ring, the only formula that I know is sigma into area. The reason why I couldn't use it on the whole disk is because sigma is changing everywhere. Isn't it? Think about it. When you found out area under the curve, what is area of a rectangle? Length into breadth. Do you know any other formula for area? You don't know any other formula. But when you took a random curve, you said, I will take such a small piece, I'll assume this is a rectangle. So I'm doing the same thing. I'm taking such a small thin ring, I will assume sigma is constant. So sigma is given c into x, and this is 2 pi x into dx. This is mass of one thin ring. So if you want the full area of the disk, you have to add all of them. Add means summation. Summation means integral. So this would be 2 pi c, and that would be x square dx. X square integral is x cubed by 3. Put limit 0 to r, and that would be 2 pi c r cubed by 3. Please have a look at the steps. So the whole idea of the question is, you took such a thin ring, you can assume sigma is constant, which is not. But for the thin ring, it is constant. Have a look at the steps. Let's see one more like this. You guys can do it. After doing multiple problems, you'll get the hang of this. Anyone not convinced with how did I take an element? Why am I doing this? What is this? Anything you're not clear, please ask. You can just unmute and ask. If you're still feeling shy, you can just leave a message in the chat box. But I would prefer if you can just unmute and ask. Nothing to feel shy. All clear? So you guys will do one thing like this now. What was the last question? Second, no? You guys try then. So I have a non-uniform disk. Sigma is 2x plus 1 kg per meter square. Means for every 1 meter square, the mass is 2x plus 1. It's not constant, meaning at center, mass is 1 kg per meter square. At the outside, it is different. The radius of the disk is 3 meters. X is the distance from center. Find the mass of the disk. Hope everyone has solved the paper again. Everyone resolved the paper, right? Exam ka assignment. So we will discuss end of the session. Let's get this. You want? I'll show the reference thing. You can just put down this thing. Sigma is this and R is 3. You need this much data. Have a look at this and try to solve. So the only difference will be, यहाँ पे the sigma is there, no? This will become 2x plus 1. Isn't it? That is the only difference. This will become 2x plus 1. Everything else is same. You can refer this and solve. Try. 3. Let's see. (45 pi, 12 kg, 42 pi). We have 3 different answers. Let's see. So we have a disk at a distance x. Take a thin ring dx. So area of this ring is 2 pi x dx. Agreed? Now mass of this ring, so dm is mass of that ring, is sigma into area, but sigma is given as 2x plus 1 into 2 pi x into dx. So which is 2 pi 2x square plus x into dx. So mass of that disk is, add all the rings. The moment you say the word add means you're saying integral. 2 pi is constant, it comes out 2x square dx plus x dx. Limits will go from 0 to 3. This also will go from 0 to 3. 2 pi is whole 2 pi. If you have reached till here, question is over actually. This much integration you can handle. This guy would be 2 will come out, and the x square dx is x cubed by 3. Limits will go from 0 to 3. X dx is x square by 2. Limits will go from 0 to 3. 2 pi, that is 2 by 3 into 3 cube. That is 0, so I won't write. This is 3 square by 2. So 1, 3, 1, 3 will cancel. That is 9 to 18. And this is 9 by 2. 36, 45 pi kgs. Yeah. Sania, Harush, you guys got it. Others, please check. Anyone not convinced with this, please ask. See where you're confused or where you messed it up. So the moment you see a disk and something is messed up with the disk, this is one way to choose elements. There is another way, but we will see them later on. Let's not put everything together. The first time you'll encounter this kind of problems, right, is center of mass collision. So I think that is fifth, sixth chapter, I guess. So we will do few models right now, because then when I teach you again, at least you will know, we have done something like this. So if I teach you this later on suddenly, right, you will feel like, oh, everything is new. You should know actually how we are going to use integration. This is what I was saying. Integration is actually easy. The headache is this problem only. Converting into integration. All clear with this? Anyone not clear with this? Any step? Devansh, Devika? Clear? Pushkal? Aditya? Got this? Arush? Kaushambi? Clear? Perfect. Next one. Volume of a sphere. Any ideas how to choose an element? So the most important thing is, how do you choose an element? It's a sphere, radius r. When I draw the diagram, both will look same. So yeah. How do we choose elements here? So there are two ways you can choose elements. You can take elements as thin shells, like an onion ka shells, onion layers. Or thin discs. So both have their own merits, especially when you see this thing. So this is what you do. You'll take a thin disc like this, thin disc like this. You're getting how I'm taking elements? Like this. Layer upon layer, layer upon layer. Meaning if you take a watermelon and if you try to cut it like this, you will see something like that. So how do we do this thing? So let me show you one and then I'll ask you one more. So I will choose the elements as a shells. So idea is the same. At a distance x from center, I'm unable to draw 3D figures, so the disk and this will look similar. So be careful. So this is a thin shell, thin hollow shell with thickness, like your plastic ball with air inside. Now, what is the volume of this thin shell? The volume of thin shell, can I say like this? Surface area into thickness. Area into height should give you the volume. So here I'll take the surface area into thickness. What is the surface area of a sphere? So the small volume of a shell dV is 4 pi x square into thickness is dx. So if I add all this volume one after another, what do I get? So volume of the sphere is summation of all these thin shells, which is 4 pi x square dx. The first shell will start in the center. The last shell will be outside. So limits will go from 0 to r. 4 pi integral x square dx from 0 to r. So this is 4 pi, that is r cubed by 3. That is the volume of a solid sphere. Clear? I hope you're getting the difference between the elements. This we did today only before your class. here. I was teaching them the same thing here. We are taking small volume here, 4 pi r square dr square. You can see. So here I wrote, see the green one, the thin shell. So this will be ideas there. The problems will be like more complex. But the idea starts from here. Please have a look at this example. Clear? Achita? Clear, no? Ideas clear. Archana? Anish? Clear? Soham? Sanya? Now you guys try. Fourth question. We have a non-uniform solid sphere. How does this look like? Think of how does this look like? Coconut. It is not same everywhere. Watermelon inside is same but outside is different. Kinder Joy. There are also different layers of chocolate. Something of that sort. Or Ferrero Rocher. That is definitely non-uniform sphere, isn't it? So Earth, perfect. Earth. The non-uniform sphere. Let the radius be 2 meters. Rho is called volume density. This is what you studied in school. Mass per unit volume. So here rho is given by 3x. Means it's not constant, it is changing. So x is the distance from center. Means at the center there is no mass, and as you go outside, the sphere is becoming heavier and heavier. Distance from center, x ka value lies between 2 to 0. Find the mass of the sphere. Think how do you do? I'll show you in a minute. On 28 pi by 5. Okay. 243 pi. Hmm. So at a distance x, take a thin sphere dx. So dV is volume of the thin shell. Think of a balloon. It has volume, but if you see the thickness is very thin, which is surface area. 4 pi x square into dx. Again, the same logic. Since thickness is so small, I can assume density is constant for this thickness. That is the whole point of integration. That was the whole story I was trying to teach you last class. You take such a small thickness, that curve will start becoming like a straight line. You can ignore that error. Rho is constant for this thin shell. So mass of this shell dm. See, it is important you always take a small thickness. Why are you taking thickness? If you don't keep thickness, how will you get layer upon layer, right? So mass of the shell, which is rho into dv. Rho is 3 into x. dv is 4 pi x square dx. Bas ho gaya, you created the function. So mass of the sphere is summation integral dm 4 3 is 12 pi integral x cube dx. Limits will go from 0 to 2. X ka value is going from 0 to 2. This is 12 pi. X cube is x power 4 by 4. Limits will go from 0 to 2. This is 3 pi and 2 power 4 minus 0 power 4. 48 pi kgs. Why didn't anyone get this? Did I goof up? Check out, see where you messed up. Or did I do a mistake? Brijesh, your cam is blank, right? I can't see you. Okay, we have one. Arush got the same. Limit is 0 to 2, na? Radius is 2 meters only. Maybe that's why you got 243, I guess. Please check out the working, everyone. Anyone not convinced with this, please ask. Devansh, clear? What happened, Devansh? Tired? Just finished your food, you're sleepy?
Sir, I got 32 pi as answer. Did a calculation mistake.
Yeah, okay. Devika, clear with this? Got it, no? Mrudul? Got it. Kaushambi, clear, no? Archana? Hope everyone figured out your mistakes. Om? Great. Let's see something more interesting. Now, you guys give it a try. I'll give you some time to try. Turn in the page. I'll send you a small sheet on this, 5-6 questions like this. This is how I want you to learn integration. If this is the actual integration we require for physics. Correct? And max may they will teach you all that is different. We don't need that. So we have a hollow shell. Radius is r. Someone filled it with liquid up to height h. And this is your center. You get it? So hollow shell, it is partially filled with liquid. It's partially filled with liquid up to height h. Find the volume of the liquid. Is the question clear? You took a sphere, you didn't fill it up completely. You filled up only up to height h. There is no formula for this, huh? In school or anywhere, you never learn anything like this. But this is a possibility, right? This is what happens in real life. Every time, who will give you full sphere? Happens. You break a coconut, you will find a water like maybe half filled or quarter filled. You can buy a Kinder Joy, maybe in that there is no full chocolate. Happened with my nephew last time. He was jumping and crying that he wants a Kinder Joy for 2-3 weeks. Then his mom finally agreed. They went to the shop, they bought a Kinder Joy. He was so happy. Then he took it and tried to eat it, and inside there is a big cavity. For some reason, there was a chocolate missing inside the Kinder Joy. This guy started crying. It is cheating. I didn't get the chocolate. His mom said again next month. So that is how kids' dreams are broken. So there are first thing, how will you choose your element? That is the first thing you need to do. I'll ask you one thing. So listen. If this question comes in the exam, okay, and options will be given. I can't give you the options. Can you tell me how will you guess this question? This is an important skill. If you can guess the question, you should guess it. But guessing requires more knowledge. हाँ, guessing मतलब again inky pinky ponky head and tails वो guessing नहीं है. So can someone tell me if this question is given, how will you guess this? This is a skill which you need to learn. Because see, that is how you get speed in the exam. When I was in 11th, right, one of my friend, Sabir, he's pretty good in physics. He's the guy who taught me physics. Many concepts. He is better than me in physics. But he never scored more than me in physics. So this is something which you need to understand. Just because your subject is good doesn't mean you'll perform well in the subject. Because Sabir always had this concept like, I will think about it. Let's see what is happening. He's very good in analysis. But when it comes to exam, he's pretty slow. So when we wrote AIEEE exam, that is a JEE mains, my rank was All India 185. His rank was 9,000. That exam had 180 questions in 180 minutes. It's a pretty fast exam. One question, 1 minute. But when he wrote the advanced exam, my rank was 360. His rank was 670. Because advanced exam gives you more time per question. So Sabir was able to do better. Maybe if it is physics Olympiad, he will do better than me. Because physics Olympiad, they'll give only 3 or 4 questions for 3 hours. So meaning as the questions become more and more complex and more tough, Sabir will start doing better than me. But if it is about like a fast round and lots of questions, I do much better than him. So if this question was given, anyone, can you tell me how will you guess this? Any ideas? Think for 30 seconds. Then I'll give you some hint and let's see whether we can guess this. Later on, when you're in 12th, right after the portion gets over, we'll have 1 or 2 tests where you have to guess all the questions without solving. Let me ask you this thing. Suppose if h is equal to 2r, what does it mean? If h is equal to 2r, what does it mean?
Completely filled.
That means the sphere is fully filled. If the sphere is fully filled, what is the volume? 4 by 3 pi r cubed. That means in the 4 options which you have, if you substitute h is equal to 2r in all the 4 options, whoever does not give 4 by 3 pi r cube are wrong. Making sense? I don't know who is the answer, but I know who is wrong. That is the whole concept of guessing. While guessing, you can never find the right answer. You can find the wrong answers. Are you clear? Can you tell me one more data point? There is one more way to guess. There is one more data point. There are actually 2 more data points. If suppose h is equal to 0, what does it mean? There is no water. The volume is 0. So if you put h is equal to 0, I should get 0. Whoever doesn't give 0 is wrong. Suppose if h is equal to r, then half filled. You're getting what we're doing? We are converting the problem into something which I know. I know for full sphere, I know for half sphere. You're asking me for some random h. So if I can make h is equal to r, The answer should be 2 by 3 pi r cube. Substitute. Maybe this is also wrong. The only thing left is D, so that should be right. If it is an exam like mains or bits, you'll be able to guess questions. At least out of 25 questions, you'll be able to guess 1 or 2 questions. If it is CET exam, you can guess even more. Bits exam, you can guess more. Advanced is very difficult to guess. Maybe you'll eliminate 2 options. So CET exam, when I was writing, so this is, like I said, it is a skill. Whenever I see a question, first thing I always try to guess. If I can't guess in 10-15 seconds, I start solving. So what I do for that, so there was a big question in maths, huh? There was like 7-8 lines of question tha. So I was reading some important words I was reading. And it was like integral x square, blah, 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 big function, deadly function it was. I saw the function and said like, what the hell is this? I said, theek. Then the question was find mod x. Options are -1, -2, -3, 1. Now, do I need to read the question? Do I care what is the question? Mod x is always positive. This is the only answer. I marked it and went to the next one. I don't even know what the hell the question is. This was CET. And my rank was 359. I'll tell you the biggest advantage. The moment you guess the question which would have taken 2 minutes, you solved it in 10 seconds or 15 seconds. Didn't you save time for some other question? You save time for some other question. Second, you feel very good about it. During the exam, feeling good is very important. Because during the exam, if you're always tensed and worried, right, you won't perform up to your maximum. But if you're happy and feeling good about yourself, you will enjoy the exam. Writing an exam feels like, you are doing something for fun. You ask any person in top 1,000 ranks, huh? You ask them, how did you feel in the exam? They say it is fun. That's the most important thing. If they didn't get a question, they will think, okay, I didn't get something. Let me see how to do this. That is the kind of attitude they have. But the problem, we panic too much and we mess up even what we get. So let's see how to do this, but listen carefully. So for this, we will choose elements are disks. Because here taking shells doesn't make sense, right? If I take a shell like this, is there any water here? There's no water there. So from here at a distance y, take a thin disk. Whose width is dy. Since you're going in the direction of y, you take a small dy. So what you got is a thin disk like this. Are you able to visualize how is this disk? See, listen. You take a watermelon and you take a knife and cut it like this. You'll get a disk, right? Pizza. Getting it? So you got a disk. What is the radius of this disk? This is radius r. This is x. Pythagoras theorem. R square is equal to x square plus y square. So x is equal to root over r square minus y square. This is the radius of the disk. What about the y coordinates? At this point, y is equal to 0. Now, again, when you look at the limits here, remember this is h. So this point y is equal to 0. This point y is equal to r minus h. This point y is equal to r. So can someone tell me water is from where to where? Where does water start? R minus h. Where does water end? R. You got the limits? That is how you get limits. What is the meaning of limits? Where are you starting from? Where are you ending? Your water starts when y is r minus h and water ends when y is r. And this guy ka radius is x and this thickness is dx. Isn't this a small cylinder? Isn't this like a small cylinder? So what is the volume of this thin disk? So volume of this thin disk is dv, which is pi x square into dx. This thing kind of looks like cylinder. Radius r and height h. Now, if you feel like, sir, itna idea kaisa aayega? That's why I'm teaching you, na? Now you know. If you see something like this, you should not mess up that way. So we got volume of thin disk. So what is volume of water? Add all these thin disks. Volume of water is integral the volume of thin disks. So that would be integral pi x square. Sorry, this is dy. dy. But what is x? X square is r square minus pi square. So this is pi r square minus y square dy. Limits will go from r minus h to r. Tell me, is that integration difficult? X power n ka integration tha wo. Please have a look at the steps. In the next page, I'll show you the working. Again, the idea is at a distance y from the top, I took a thin layer of dx. Uska radius is x tha. So what I got is a thin cylinder of radius x and height dy. The volume of the thin cylinder is pi x square dy. So now I'm going to add all these thin cylinders. I'll get that water. Do have a look at the steps. Anyone not convinced with this? Anyone, anything that you feel like, oh, what is this? Please ask, don't hesitate. Get it cleared. Clear? Great. Now let's integrate this. So volume of the water is integral pi r square minus y square dy. Actually, ho gaya. Physics got over. Now it is all maths. Take out that pi common. So integral r square dy minus integral y square dy. I'll put the limits later. So pi, this is r square y. Limits will go from r minus h to r minus y cube by 3. Limits will go from r minus h to r. Integration is actually quite simple there. Now substitute the limits. Pi r square. So r, put the upper limit, minus put the lower limit. Minus 1 by 3 r cube minus r minus h whole cube. Simplify this. Pi, r will cancel. You end up with r square h minus 1 by 3. This guy is r cube minus 3r square h plus. Everyone knows, right? A plus a minus b whole cube. I hope you know how to expand that. 3r h square minus h cube. So this is r square h minus 1 by 3. R cube will cancel. This guy will cancel. You end up with minus of minus is 3r square h minus 3r h square plus h cube. And if you observe here, this and this will cancel. Like I said, it looks big and dangerous, but everything cancels out actually. R square h and minus minus is plus r h square minus h cube by 3. This guy and this guy goes off. You end up with pi into h square r minus h by 3. Now let's see and see whether the answer is coming right. Suppose if h is equal to, if h is equal to 2r, we are getting pi into 2r whole square r minus 2r by 3. So that is 4 by 3 pi r cube, right? Now, this is what I was saying. If you substitute h is equal to 2r, the answer should give 4 by 3 pi r cube. Suppose if h is equal to r, volume is pi r square into 2r by 3, 2 by 3 pi r cube. Making sense? So exam you'll have options like this. Options will be given like this. Pi h square into r minus 2h by 3. Pi into r square into r minus 2h by 3. They'll give like this different options. So when you keep substituting values, you'll get different answers. So I'll just write down the answer here. So this volume is given by pi h square r minus h by 3. There. Please have a look at this. This is just lengthy. It's not tough. If you get a question like this, the best way to do is guess. Maximum you'll be able to eliminate. You'll get the answer. Put h is equal to r, put h is equal to r, you'll be able to eliminate 3 options. The whatever is left is the answer. It's very difficult to frame options for this. Then now just imagine a person who solves this entire question like Sabir, a person like me who guesses and get the answer. Sabir would have wasted at least 3 minutes minimum. No matter how fast you get, to still take 3 minutes. I would have finished this in 20 seconds. Didn't I get an advantage? I have a momentum also now. My questions are going faster. I'll be more confident. Whereas Sabir will start getting frustrated after some time. Like, what shit, what calculations are these? Karke? Please have a look at the steps. There, now you know how to find volume for even a partially filled sphere. We created a formula. No need to mug up. I just wanted to get the idea. All sure with this? Anyone has any doubt on this? Again, like I'm saying, tomorrow, today, sit. After that, tomorrow, maybe take a paper and try to do this again. Tanish, clear, na? Can I go ahead? Now you guys try this. Solid cone. You know the answer already. Find the volume of the solid cone using integration. So this is radius r. This is height h. Again, how will you choose the elements and how will you integrate? Let's go. Think. How will you choose an element? Just give it a try and get some water and come. Hmm. How do we take elements? Anyone figure out the elements? Did you ever take a carrot and cut it? If you take a carrot and cut it, what do you get? You get small discs, na? So basically, this is nothing but multiple thin discs. You can take discs like this, isn't it? So if you can add all these discs, you will get the thing. So here the elements are thin discs. Getting it? So in this entire thing, if you can remember what shape is what element, I think you got the point. It's okay. It's okay if the remaining part is little confusing. Don't worry too much about it. That you will grasp it as we go ahead. But the main thing, moment you see the diagram, you should know what is the element. Now, how do you think we should proceed? See, from the top, this is the y-axis, no? So I'll take distance y from the top. I will take a thin disk whose width is dy, whose radius is x. This angle is theta. Now for the whole cone, this theta is constant. This was radius r and this was height h. So tan theta was opposite side r by h. But the tan theta is also equal to x by y. Agreed? Similar triangles. Now you take a thin disk. Basically, it becomes a thin cylinder whose radius is x and thickness is dy. Doesn't this look like same as previous one? The elements will look similar. Doesn't matter what shape it is. Then the volume of this thin disk, dv, is nothing but pi x square into dy. But what is x? X is y into r by h. So pi into y square r square by h square into dy. Can someone tell me what is y ka value? Y starts from 0 and y goes till h, isn't it? So your disk will start at the top and will go till the bottom. So you're done. So volume of the cone is integral dv pi r square h square integral y square dy. Limits will go from 0 to h. So this is pi r square h square. This would be y cube by 3. Limits will go from 0 to h. That is h cube by 3. 1 by 3 pi r square h. Isn't this what you learned in school? Volume of the cone. Please have a look at the elements. Anyone not convinced with this? Any steps you're not clear? All sure? Next one. This is very important. You will see this at least in 1, 2, 3, 4, at least 5 chapters. So you'll see. So we have a sphere. Radius r. This is your center. So this part of the sphere is coated or painted something like this. This is angle theta. Find the surface area of the shaded part. I don't want full area of the sphere. Find area of the shaded part. Basically, this is a part of a sphere, isn't it? I just want area of that shaded part, which is making an angle theta with the horizontal. Radius is r. So basically, this is a part of a sphere. Can someone tell me how will you guess this? I'll show you how to do. It's a little difficult for you guys, but let's see. Later on, you would have handled it, but for now, it's difficult. But can you tell me how will you guess this? How will you guess this? To make it full sphere, theta should be how much? देखो ना, if you want full sphere, theta should be completely till here, na? You're getting this? See, at this point, theta is 0. Here, theta is 90. So if you put theta is equal to 90, what will you get? Theta is equal to 90 will give you half sphere, isn't it? The answer कितना आना चाहिए? 2 pi r square. If I put theta is equal to 180, means you have completely gone this side, means it will be full sphere, no? The answer should be 4 pi r square. Are you getting how to guess? So by putting different values of theta, I will get the areas. I know the area of full sphere, I know the area of half hemisphere. So theta 90 gives hemisphere and theta 180 will give you full sphere. From there, I could guess it out. So listen, let me show you how to do this. Like I said, the result is more important. I'll write down the result. So area of the shaded part, you will encounter this in, I think, the 3rd or 4th chapter. Is 2 pi r square 1 minus cos theta. This is your answer. Definitely remember this. Let's see how we got this. I will not take the full thing. I'll just take this part. So this is your center. So at this point, theta is 0. So let's say like this. Listen carefully. At an angle alpha, take a thin slice like this with a small angle d alpha. What you get is a small ring like this. So at this point, alpha is 0, and at this point, alpha is theta. So you're changing alpha for small instance. So what you get here is you get a band like this. Where this length is r into d alpha. Remember arc length? So if you see, this angle was d alpha. This was alpha. So this side, opposite side is r sine alpha. I'll tell you how is the element C. Take a watermelon, cut it horizontally. You will get this watermelon with the red color thing in the middle. Na? Remove the red color part. You'll be left out with a green color band, isn't it? Able to visualize? Take a watermelon, slice it horizontally, you'll get a disc. Remove everything in the middle, the red part. What is left is a green color band. Make sense? Now take a scissor, cut it. The moment you cut it, you will get a rectangle whose circumference is 2 pi r sine alpha. Remember the radius is r sine alpha and the width is r d alpha. Choosing an element is important. ये idea ना बहुत important है. Meaning this you will encounter like anything. मतलब multiple times you'll encounter like this mark. I'll show you when it comes, but not a single time. For example, center of mass collisions mein, this is the first time you will see in more detailed. I'll show you where is the first time. See, it's like friction when we do here. This was the question. See, area covered in dust. So we get an answer like this. We'll encounter this. Later on, in another chapter, we'll encounter this. Here, we get elements like this. You'll see this thing. 5-6 chapters, like it's a pretty common integration. So the point is, because now you have seen this, it is difficult. Second time when I show you this, instead of 100 difficulty, now you'll think it is 80 difficult. When you see for the third time, you'll think 60 difficult. When you see for the fourth time, you will think, okay, 30 difficult. After fifth time, you'll think like, chalo, abhi ho jayega mera saath. You're getting it? I'm not expecting you will immediately grasp this. I hope everyone's getting the basic concept what we are doing, right? So I'll tell you again, this is one thing understand. School nahi hai. School mein teacher will teach you something, next day you understood everything. Your school ka curriculum was bullshit. It was way below your level. It was way below your intelligence level. School ka curriculum is designed so that everyone passes. School ka curriculum is not designed to make sure, you reach your potential. If school ka curriculum was really designed, to make you think and understand, 90% people will fail. And people, and parents are not sending, students to college schools and paying so much fees not to fail, right? Just think about it. School mein, if someone tells you, we will give you knowledge, we will give you marks, people will take marks. Because getting 95% looks cool, right? No one gives a damn about that, how to integrate and solve and everything in 9th standard. So that's the problem. So your school ka curriculum was designed, so that everyone passes. And that is everyone passes, meaning you have to make sure, for example, if 100 marks is there, let's say average is 40. If you want even the weakest student to pass, meaning the guy who can get 20 marks also should get at least 40 to pass. Means you design the curriculum to be at least somewhere at 20 or 25 level. You guys did this nonsense and you thought you guys are geniuses. So think about that. So what is the area of this? Now I can tell you that confidently. Why? Because 3-4 years back, I used to take foundation. I used to teach all this stuff in 8th standard and kids used to understand. Tell me one thing, whatever I'm teaching, is it really that difficult to understand? Maybe thoda calculations and all are there. So what is the area of this thin strip? Length into breadth, 2 pi r sine alpha into r d alpha. Ho gaya. So that means if you want area of this part, this is the area of the shaded part, is integral dA, which is 2 pi r square integral sine alpha. I said integration is actually easy. Dekho. Limits will go from 0 to theta. What is sine alpha ka integration? Minus cos alpha. So substitute the values. Put cos theta. Put cos 0. Cos 0 is 1. So your answer would be 2 pi r square 1 minus cos theta. And that minus sign is looking weird actually. I hope the answer is clear. Quite a useful integration. We will again encounter this. So example. If I give a disk like this, if you want to find this shaded area, and let's say this angle is 60 degrees, then using this formula, you will get 2 pi r square 1 minus cos 60. Cos 60 is half, so pi r square. Like that. So for different values of theta, you get different areas. Clear? Next thing. Now I'll give you something as homework problems. Give it a try. Next class we'll be discussing them. Suppose if I have a shape like this. This shape is called a paraboloid. You have seen this shape, you just don't remember it. This is how it would have looked. Did you ever rotate water in a bucket? I think maybe this is better. It's the same thing actually. So whenever you spin water in a bucket, this is how the water looks like. This would be even better. Able to visualize how is the shape? Bowl kind of shape. If you fill the bucket with water, half bucket, and then rotate with your hand, this is the shape you see. This is called a paraboloid. So this point is origin 0, 0. This height is h. This radius is r. So this equation of this curve is y is equal to one second, x square, we keep x is equal to h by r square into x square. That is the equation of this paraboloid. So this curve ka equation is this. Meaning this is the relation between y and x. So I want you to find, there are too many diagrams now. Okay. So find volume of this paraboloid. Try this as a homework. Next class we'll discuss this. Just to give an idea, we will take thin disk like this, na? Disk. It's a good one. This we will see in fluid mechanics. Spinning water in a container. Great. Now let's see paper ka doubts and this thing, and we anyway have a PTM at 10:30. So let's see. Let's finish up at least the paper ka doubts. If there are too many, then we will see.